Hey guys, Mr. Gucci here to help you with your 9.2 worksheet mole volume conversions. Now listen, mole volume conversions are much easier than mole mass conversions for one simple reason, and that is that 1 mole of any gas will always occupy the same volume in the same conditions, all right, under the same conditions. It's not like one type. So for example, the number we're looking at is 22.4 liters per mole, all right, 22.4 liters per mole. That is how much volume 1 mole of any gas takes up, right? So if you have, like, say, 1 mole of H2O, that's going to take up 22.4 liters of space. If you have 1 mole of carbon dioxide gas, it's going to take up 22.4 liters of volume. If you have 1 mole of helium gas, again, 22.4 liters. It doesn't matter that a water molecule is about 4 times larger than a helium atom. They will take up the same volume, okay? Or that, say, a carbon dioxide molecule is 11 times the mass of a helium atom. They will take up the same volume. Now, this is a huge amount of expansion, okay? Just for reference, 1 mole of H2O, all right, is about 18 grams of H2O. That's not a lot. Your average water bottle that you drink, all right, like your little handheld water bottle you get at the store for like $1, that's 500 grams. Okay, so 18 grams of H2O is like a sip. And yet, when you turn this water into a gas, it will occupy the equivalent of 11 2-liter soda bottles of volume. Okay, water expands a lot when it turns into a gas. Anything expands a lot when it turns into a gas. Okay, that's 22.4 liters. So 11 2-liter soda bottles plus, like, a little tiny bottle. Okay, all right. So again, stuff expands a lot. It doesn't matter how big the molecule of gas is, because it expands so much. It takes up so much space that the volume of the individual particle doesn't really factor into it that much. And so you're left with this simple conversion that 1 mole of gas, 1 mole of gas equals 22.4 liters, okay? And this makes your conversions real simple. If you're going from moles of gas into liters, well, just like before, if you start with moles, you multiply by 22.4. If you start with moles, you multiply. If you're going from liters into moles, then you're going to divide by 22.4. Again, it doesn't matter the type of gas. You don't need a periodic table for this, all right? You need a periodic table to figure out the molar masses of the other guys, but here, no periodic table. The number is 22.4 regardless of what the type of gas is. Okay, so let's look at this homework. Okay, let's take a look at this homework. So 150, by the way, don't forget, put in your name. I'm DJ Goochmeister. Sorry. I am Mr. DJ Goochmeister. I am a professional. I am Mr. DJ Goochmeister. And my student ID is, let's say, 654321. Okay, so I have 153.19 liters of chlorine gas. All right, and it is comprised of how many moles? Okay, well, let's see here. I'm going from liters into moles. Liters into moles. So if I go by liters into moles, I'm dividing by 22.4. So 153.19 divided by, let's see here, liters, divided by 22.4 liters per mole. And I get, and the good thing about typing this up here, guys, is that I can just paste it into Google. Just eliminate those. Oh, does it actually process? Like, oh my God, that's so cool. It knows the units and stuff. Oh, Google, you crazy. 6.84. 6.84. Oh, it gives you the units? God damn, you guys aren't going to have to think at all soon, are you? All right. So 6.84 moles. 6.84 See, it does in the work section. Control Z, Control Z. 6.84 moles. Great. Great, great, great. But see how easy that was? If I'm going from liters into moles, 0.19 liters, I'm dividing by 22.4 liters per mole. Okay? Cool. Cool, cool, cool. All right, and then it goes the other way. 45.67 moles of oxygen gas will occupy what volume? Well, I'm going from moles into volume in liters, okay? And if I'm going from moles into liters volume, I multiply by 22.4 because every mole is 22.4 liters. So if I have 2 moles, that's twice as much. If I have 10 moles, that's 10 times as much. Okay? So I will do 45.67 moles times 22.4 liters per mole. And I will just put this into Google. Can it solve this? Can it? Oh, look at you, Google, you fancy. 1,023 liters. 1,023 liters. Okay, so the answer is 1,023 liters. Wow. See, look how easy that is, guys. Look how easy. Again, it's just the number 22.4. When you're doing mole to volume conversions, you don't need to access the periodic table. Notice how there's no periodic table up here I'm looking at. It doesn't even matter that this is chlorine gas here. It could be any gas, all right? I just had to fill in the space here, okay? All these gases here are interchangeable because it doesn't matter what it is. This could have said fluorine gas or carbon dioxide or oxygen. It would still be the same answer, okay? Because it doesn't matter the type of gas. Now, some of you might be asking, Mr. Gucci, how can all gas take up the same volume? All right, because I know that gas expands. Like when you heat up gas, it gets bigger. That's how hot air balloons work. And I know that when you chill gas down, it gets smaller. It takes up less space. That's why you sometimes get flat tire indicators on your car when it gets cold out in the winter. Your tires aren't actually getting flat. It's just slowing down the gas particles, and the particles are condensing. Well, this 22.4 liter per mole value only holds under specific conditions. It only holds under, okay, so let me see here. So 1 mole of gas takes up 22.4 liters at 0 degrees Celsius and 1 atmosphere of pressure. If you increase the temperature, then the gas is going to take up a greater volume, more than 22.4. All right? If you increase the pressure, then the volume will go down, like you squeeze it together. Okay, we're going to learn more about this in chapter 12, I think it is. But for now, all you need to know is that this 22.4 liter number is specific to 0 degrees Celsius and 1 atmosphere of pressure, which we call standard temperature and pressure, or STP. All right, the standard temperature is 0 Celsius, and the standard pressure is 1 atmosphere. So you'll see this STP pop up a lot in your homework. Just know that that STP represents that these are the conditions in which this 22.4 number holds. And then you're like, but Mr. Gucci, what about when it's not 0 degrees Celsius or 1 atmosphere? Well, I'll tell you this. In a later chapter, we are going to explore what happens if the temperature goes up or down, or if the pressure goes up or down, and how that changes this number right here. But frankly, that's too much for what we're doing in this chapter. So right now it's 22.4. Know in the future we'll figure out how to adjust this number based on changing temperature and pressures. But right now, going from liters into moles or moles into liter, you're either dividing by 22.4 if you're going from liters into moles, or multiplying if you start with moles and going into liters. Remember, if you start with moles, you multiply, right? Anyways, guys, that's your homework. The first 6 problems are just multiplying and dividing by 22.4 liters per mole, okay? The next 4 on the bottom, we'll take a look. I've got a few volume, a few liter mole conversions, so the 22.4 stuff, but I've also got some molar mass stuff. So you're going to have to, for some of these problems, number 7 and 8 in particular, you're going to have to dust off that periodic table. Okay? So for numbers 7 and 8, you're going to have to dust off those periodic tables to get this done. All right, guys, I hope this helps. I hope this has been a useful video to you. Can I stop this video? Do I have the power? Am I in control of my own computer? Here we go. And